Hello, as you can see I'm in the workshop and this is going to be part 2 of the Jester build, and just do a quick pan around. I've done a pretty thorough cleanup. There's still a few things I haven't decided where to store. I think I'm going to put a shelf up there for my lathe tooling, and I'll just spin around. I think I might put a shelf in here for my mill tooling. Some of that's sitting there at the moment. And I bought a stand for the vise and I bolted that to the floor, but I'm not happy with the stand. It's got a little bit of flex to it and I was a bit disappointed with that. It wasn't cheap and I'm probably gonna have to replace it already, but I'll make it work for the time being. So tonight I am going to just talk about the 3D printed parts and the tubes, and I'll show the drawings. I've got my bike in the stand because I want to talk about an aspect of that is part of the design, and let's get to it. Hello, I'm back at the bench. So as you saw when I was showing you the model on the computer, normally if these was going out to someone else, there would be a set of drawings that would be really detailed with heaps of info and lots of dimensions. But because these drawings are only for me to use, I have put only the dimensions I need to set up the jig, to cut the tubes, and to then position them. There's nothing else. There's no internal dimensions or anything like that because all of that's already set. When I sent the models off to be printed, they already come back. So there's lots of aspects on these that I don't need to refer back to in the workshop. So it cuts down on the complexity of the drawing. So these drawings, I have a main frame drawing. I also have a drawings to set up the swing arm and the seat stay section. So on those drawings, there's only the jig setup dimensions and then the tube cut and position dimensions. So it keeps the drawings a lot easier to read, and I'm not sort of chasing dimensions or anything. Everything's there that I need. So these are the tubes for the Jester. It's a 38mm down tube, 35 top tube, 38 seat tube. I use fork blades for the seat stays because they're nice and strong, and then chromoly tubes for the swing arm. So I showed you the bottom bracket section of the 3D printed parts the other night. This has the threads for the bottom bracket and the bearing seats already machined. I got them to do that in their factory before they send it all out. I will set it up in the mill and just skim the inside of the lower shock mount. And on this frame, Jack's only wanting to use a normal dropper post, so I'm just going to make some nice aluminium plugs or even some stainless plugs to just plug into that, which we'd be able to knock out if you wanted to. So that's that. That's the head tube. It's got the dropper post port, which is stainless tube. It goes up into a socket on the inside. There's also the port boss for the steering damper. It needs a notch in the top tube. Once I square cut that around. If you're never ever going to use a steering damper, there is potential for that to be filed down, and I'll fill it in and close it up if you don't ever want to use it. That's the head tube. That's the main rocker pivot. It goes on to the seat tube. Because of the printing tolerance, some of these parts don't fit too well yet. So I need to sort of just grind a little bit on the outside. That just slides on, gets positioned at the right height and squared up, and then gets brazed into place. It's become something that has took me many hours to do in the past. Saved me a lot of time by doing it this way. The seat tube is segmented, so 0.9 wall thickness at the bottom, and at the top it's 1.6. It will get machined internally and externally to drop some of the weight out of it and just give a little bit of compliance. It gets spliced together, and then that goes onto the bottom bracket assembly like that. And I think I still need to take a little bit off the top and a little bit off here, so that when this gets brazed on, there's a little bit of overlap. So this is into the strong part of the tube. So that's that, and I'll explain a little bit of that in a minute, why that's made like that. And what else have we got? So that's the front of the swing arm. It gets the tubes, right? See that printing tolerance and a bit of prep on the tube. Tube gets a 108-degree bend put in it, and that will 108, something like that. That will get cut to the right length, and then the tube brazed in there. And then on the other end of that is the front of the horse link pivots. So the other thing that happens here is the rear derailleur cable goes in that front port, runs through there and out there, and then there's a stainless tube that runs from that port and then runs down the inside of the swing arm and comes out at the back there. So again, that seals the tube, the swing arm off. So any water that gets in down past the housing stays within that guide tube. It doesn't go into the swing arm. And even though these are stainless, these parts, the 4130 tube, while you can use frame saver or cavity sort of sprays, it's better to keep the moisture out in the first place. So that's why I do that. That's the front of the dropout parts. So we have the UDH, which I think I might have one in here. Yep. So that UDH plugs into that hole, and then it bounces against the stop there as well. So that stops it going forward and is allowed to pivot backwards. Though with normal derailleurs that bolt into a hanger, they all have their own pivoting anyway. So there is an argument to lock that into place. And I've got the ability to sort of set that the way I want by removing a little bit of material here if I need to. So, but mine are designed so that locks in hard, and the derailleur does the traditional rotating, and that gets the seat stays, it goes onto there. So that's the dropouts and the horse pivots. This is the top of the seat stay where it goes into the rocker arms. Unfortunately, when I ordered this, I pressed the wrong button and I ordered an aluminium piece. Everything else is stainless, but I pulled out the wrong material in the pull down list. So I've ordered another one of those. So I've got a bench ornament now. So anyway, and for myself, I use the steering dampener on my bike because I find it's actually really nice. It's good for a few situations, but because it's now integrated into the frame, I have a collar that goes on the steerer tube of the fork, and that then bounces against, there's a stop that's put onto the inside of that, and it stops it at 90 degrees. So it's a little bit like a Trek knock block, but you can go a full 90 degrees each direction, not the limit that the Trek knock block went at. and that's adjustable as well, so you can take that out if you're not using, or don't put it in if you're not using the steering dampener, but I am. So I've got a nice aluminium one which will replace the 3D printed plastic one that I had, and the rockers. So the unfortunate part with these rockers is that these are hollow, and one of the problems we had was we had the hole to evacuate. So when they print this, it prints, like, because of the laser, it prints like, you know, in layers, and it slowly, where's the grain on this? I think it was printed in, can't quite see, I haven't got my glasses on, so bear with me. I think it was printed in that orientation. So it gets layer, printed, and as it prints around, the powder that sits on the inside of it gets trapped on the inside. So what happens is when they finish, you've got to leave a hole in it, and then they can shake the powder out and leave the hollow structure. So what happened was when they finished that, they closed the hole up and heat treated it, and it's actually expanded the shape. You know, I don't know if you can see that on the camera. You can see that curve there, and it's curved there. They're meant to be flat surfaces, so it's actually expanded the section when they were heat treating it. And the other thing it's done is it's actually pushed, this rear part is actually now about 3 degrees off. So I probably could have kept these and used them for one of my bikes, one of the mess around bikes, just sort of as a spare piece. I still think they would be strong enough, but they're also not how I designed them. So, but because of that skew, I literally can't use them. So, which is a bit of a shame. But I got back to the fabricator and showed them pictures of it and showed them my model and what it was meant to look like. And they're printing me up a new set for free and sending that out as soon as possible. So fortunately, I don't need these rockers to put the frame together. So, which is good, because I'll take about 2 weeks to get here, so that's good. And the other little tricky part, which I'll show, is some cable guides, keepers. So I had these little ones printed up. So that's for two cables on the down tube, and then I also had a single one on, because I use electronic drivetrain. I've only got the brake housing on my down tube, so I have the single ones for those, and then I've got ones for above and below the bottle cage, and then I've got ones without the countersink in, so the bottle cage can sit on top, and I still have the housing clamped to the down tube. And that's it. I'm not going to talk anymore. And there's one thing I just want to quickly show you, and that'll be it. Not a long one tonight. Okay. So, the issue with the seat tube, and the reason why I've gone to the segmented seat tube, is I use, and I've decided to spec the frames with the integrated 8 pins integrated dropper. Now, the reason I've done that is, one, is I think it's a really cool product, but it's a much lighter seat post, and it's a lot stiffer as well. So what it does is does away with the outer casing of a normal seat post or dropper post, and uses the seat tube in the frame. And then the upper section slides in through like a wiper seal. There's a bush that sits in here, so it's an aluminium sleeve with some low friction bushings that sit in the top of the seat tube. And then the cartridge for the seat tube is anchored in the bottom, and it slides up, and then there's a piston rod which moves up and down with the seat post. So the complexity is I needed to go to a bigger diameter in the bottom to take the bottom of the cartridge, which then meant I needed to go from 35 millimeter down seat tube, which I normally use, out to a 38 millimeter seat tube. So the problem with that then is compounding. Is it's a 0.9 wall in the bottom, but I had to go to a bigger wall in the top, because on this bike I used 0.9 wall, but it meant that the bush sits loose because the OD of the bush is 35 millimeters. So there was a big gap, which I had to make some adapters to fit the bush, which was a pain in the bum, to be honest. So the splice, because this top section runs at 1.65 wall thickness, means that I end up with the bush sitting nicely. But what I will do is I will machine the inside of it out so that it supports the bush in the two spots, and then machine a little bit out to take some of the bulk out of it and some of the weight out of it, and then the splice will be where this runs, so that's supported into the strong section. Anyway, I thought I'd just try and explain that. It's taken me a long time to actually figure out how I really want to do this. If I had a chunk of money, I would get Columbus to make me exactly what I need with the seat tube. So, and there'd probably be 35 millimeter ID tube at the top, and run down and actually taper out and flare out so that I can fit it around the bottom bracket area, which meant that I can still get the cartridge into the bottom as well. So you can see where everything fits together there. Anyway, that's where we're at the moment. The next video I will start showing some of the fabrication and putting stuff together using the lathe and the mill, and see how we go. So that's, as you can see, some of the complexities of designing the bikes, and I could have made it easier for myself by using a normal dropper post. I could have stuck with a 35 millimeter seat tube, and it would be a 30.9 dropper post, but that 8 pins dropper is really, really well made and really nice and super smooth, and it's a lot lighter and there's a lot going for it, but it has made the frame a lot more complex to fabricate and design for. So, and the integrated steering damper, that was actually quite an easy modification to the design, and it would be very simple. If someone said, I definitely don't want this, I can get one of these printed up without the boss in it. I just remove the boss from the model and send the print. So the next video I will show machining the head tube. It has a section plate in the bottom which I use to hold in the lathe and then gets removed as well. And I don't have to machine the bottom bracket. I do have to machine this, and there's a bit of prep. I've got to bend the tubes and get everything in. So and that's it. I'll see you in the next video.